The second type of bonding we're going to discuss is covalent bonding. Covalent bonding occurs between two atoms' nuclei and involves electrons being shared in a common region or a common space between the two. What we find is that in covalent bondings, there is an attraction of electrons to another atom's nucleus, and this causes a release of energy, causing the electron to get trapped between the two atoms. Now, the electron can't go entirely to the other atom because there is a repulsive effect between the electrons of the other atom, but there's also a repulsive effect between the two nuclei if they start getting too close. However, the attraction of the electron is high enough that it effectively becomes trapped between the two nuclei, resulting in a shared bond. Now, when it comes time to describing covalent bonds, there are two types. The first type is known as a nonpolar covalent bond. That is, there's an equal sharing of the electrons between the two atoms. And that's really all I'm going to say about the nonpolar covalent bonds. The electrons can be found smack dab in the middle between the two elements. The other type of covalent bond is known as polar covalent. And that happens when you have two atoms of different electronegativities competing for the electron. So, for example, in fluorine, F2, you have two electrons stuck between the fluorine atoms, and they're being shared equally amongst the two. In hydrogen fluoride, or hydrofluoric acid, there are two electrons, but because hydrogen and fluorine do not have the same electronegativity, fluorine, being the more electronegative, gets the electrons in that covalent bond more often than not. The result is, because fluorine pulls harder on the electrons, the fluoride side of the molecule starts to become like an anion, or has a slightly negative charge. The hydrogen portion of the molecule, because it spends less time with the electrons, becomes slightly positive. So in polar bonds, there are slightly negative and slightly positive sides to them. Now, electronegativity is the ability for an atom to attract an electron to itself. It's not the same as electron affinity, where you actually get to deposit an electron into an element. Electronegativity is simply the ability for an electron to be attracted to another atom, but not leave the parent atom. And the rule for electronegativity is, as you move down the periodic table, things become less electronegative. If you move left to right on the periodic table, things become more electronegative. This is a trend you're going to want to remember, because you will see it again as we begin drawing Lewis structures and talking about polar molecules. So, we describe polar covalent bonds as having some distance separated and being measured in a unit called the debye, which is really beyond the scope of this class. But the take-home message is the more debyes a polar bond has, the more polar it becomes. And so as you have a higher debye count, the more polar the bond is, meaning the electrons favor one atom over the other more. So what contributes to this polar bond? Well, the bond length, obviously, the distance they're separated, and then the magnitude of the electronegativity. So here we can compare polar bonds for the halogens when bonded to hydrogen. And we can see that HF, or hydrogen fluoride, is the most polar of the group, having a high electronegativity and a small bond length. And as we continue to move down the periodic table through HCl, HBr, HI, we find that both the bond length increases and the difference in electronegativities decrease.